Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the points at which f is discontinuous, right? At which of these points f is continuous from the right, from the left, or neither? Sketch the graph of f, right? So we have f of x equals 2x plus 1 for x less than or equal to minus 1, 3x for minus 1 less than x less than 1, and 2x minus 1 for x greater than or equal to 1, right? So, like we have solved in our previous problems, we will have to examine the continuity in different intervals, right? So, we will split solving the problem into parts. And what is our part one? Our part one is when f of x takes 2x plus 1 in the interval minus infinity to minus 1, right? So, our first part is x less than minus 1, and which means that x belongs to the interval minus infinity to minus 1, right? So let's pull that out and let's call it part 1, right? And so for x less than minus 1, what is our f of x, right? Our f of x is 2x plus 1. And what is this? This is a linear polynomial which we know is continuous for x belonging to R, and therefore for x belonging to minus infinity to minus 1 open interval, this function is continuous, right? Function is continuous for x belonging to minus infinity to minus 1, right? So this is part 1, and before we go to part 2, let's examine where this function is likely to undergo a transformation, right? So we see that as x moves through minus 1, the function undergoes a transformation from 2x plus 1 to 3x, right? Because we have x less than or equal to minus 1, the function takes a value 2x plus 1 and it takes a value 3x for x greater than minus 1, right? So that is one point of importance. The other point of importance, again, we see that it happens at 1, right? Because as the function moves through 1, f of x moves through 3x to 2x minus 1, right? So, so these are 2 points which we will examine. And before that, let's move to our part 2. And what is our part 2? Is minus 1 less than x less than 1, right? And 1, right? And in this part, what does f of x take? F of x takes 3x, right? Which is again a simple linear polynomial. And we know that I'm not going to go into the details. And I would recommend that in these problems, you might want to choose a number, any number in the interval, and quickly show that the f of x is continuous in that particular interval, right? I mean, I'm not explicitly doing that because I'm again drawing your attention to some of the basic continuous functions which we discussed earlier. Be it a polynomial of the type ax plus b or x square, or be it the trigonometric function, say sine x, cos x, etc. Right? So, so I assume that you are pretty much familiar at this stage, and therefore I'm not going into uh, examining the continuity of these linear functions, right? They are pretty simple and straightforward. So with that, we know that the function is continuous for x belonging to open interval minus 1 to plus 1, right? Now let's move to part 3, where we have x greater than 1, right? And for x greater than 1, we know that f of x takes 2x minus 1, right? So 2x minus 1 again is a linear function, a linear polynomial. And what does this mean? X greater than 1 also means x belongs to the open interval 1 to infinity. Right? So at 2x minus 1, just like how we saw in our part 1, I can comfortably call this as function being continuous for interval, open interval 1 to infinity. Right? Right? So we have the three parts. So we know that as of now, apart from minus 1 and 1, we know that the function is continuous, right? Now let's examine part 4, which is x equals minus 1, right? At x equals minus 1, how do we examine continuity? Drawing your attention to what we have on the right of the screen, f of x must be defined in the neighborhood of x naught. In this case, f of our x naught is minus 1, and our f of x naught has to be equal to limit extending to x naught f of x, provided limit exists, right? So what is our f of x naught? In this case, f of minus 1, right? So it takes a value 2x plus 1. So let's write that down. F of x equals minus 1, which is taking a value 2x plus 1, right? And what is that? 2 into minus 1 plus 1, which is minus 2 plus 1, which is minus 1. And next we have our LHL. And what is LHL? We're going to calculate our left hand limit. I'm going to call out my limit symbol here. And when we mean, what do we mean by LHL? My limit is x tending to minus 1, but it is approaching minus 1 from the left, right? So when it is approaching minus 1 from the left, 2x plus 1 is still applicable. So I'm going to pull out 2x plus 1 as my function, and minus 1 again from the left means 2 times minus 1 minus h being infinitesimal, and therefore I bring this out here. My h will be tending to 0. I substitute 0, what do I get? Minus 2 plus 1, again I have a minus 1, right? So that is our LHL. Now we go to our RHL, and I'm going to pull out my limit symbol again. What is our RHL? Our RHL is our right hand limit. So when we approach minus 1 from the right hand side, right? And what is that? It means that x is greater than minus 1, right? So it takes the value 3x, right? So I will have to evaluate if the function evaluate the limit at x tending to minus 1, but from the right hand side, right? So this time I will have to substitute it as minus 1 plus h, which takes a value minus 3. We have our left hand limit, we have our right hand limit, and we have our f of x equals minus 1, right? So my LHL not equal to RHL in this particular example, right? And what does that mean? It means that the limit does not exist, right? And therefore, my condition 2 for continuity is not valid at x equals minus 1, and therefore the function is discontinuous at x equals minus 1, right? So that is how we will have to write this answer. LHL not equal to RHL. limit does not exist and function is not continuous at x equals minus 1, right? And now let's move to x equal to 1, which is our another point of importance. And let's calculate same thing for f of x equal to 1, right? And what is our f of x equal to 1? We know that at x equal to 1, f of x takes x greater than or equal to 1, right? So let's pull out this. And I know that it is 2 into 1 minus 1, which is 1, right? And I will have to work out my LHL. And what does my LHL mean? My LHL means my I'm approaching 1 from the left, right? So which means 1 minus. And when I'm approaching 1 from the left, what is the function which is applicable? It is this function 3x, right? So I will have to write that because my left hand limit will have to be evaluated with 3x, right? And what is it when I approach it from the left? I do with 1 minus h, my h being infinitesimally small, so I can pull this out this way and write this equation as 3 into 1 minus h, and as h tends to 0 I get a 3, right? And then I go to my RHL and I calculate my limit extending to 1 plus, right now. And for x greater than 1, we know that this function takes a value 2x minus 1, right? So 2x minus 1 is what I'll have to write here. And then what do I mean by x approaching 1 in from the right? So it means it is 1 plus h, right? So it is 1 plus h equal to minus 1. And what is h? H is infinitesimally small, which means that h tending to 0. And I will have to rewrite this as 2 into 1 plus h is h is 0. So 2 minus 1, which is equal to 1, right? So here we have our f of x equal to 1, and then we have our LHL, which is 3, and then we have our RHL, which is 1, right? So again, like in our part 4, we noticed that at x equal to 1, f of x equal to 1 is defined. It takes a value 1, but then the limits LHL and RHL are not equal to each other, right? So what does that actually mean? When you draw the graph, right, the value that the function f of x takes for x being very close to the value 1 is 3, and then it takes a there is a break, right, at f of x equal to 1, and therefore my LHL not equal to RHL in this case, because my RHL equals 1 and my LHL equals 3, and therefore the limit does not, therefore uh, the function is not continuous at x equals 1. I'm sorry, this is not continuous. This is again not continuous, folks. Apologies. This is x equal to 1. So for the same reason, LHL not equal to RHL, limit does not exist, and the function is not continuous at x equal to 1, right? So we know that the function is continuous at all points except x equal to 1 and minus 1, right? And we've examined the continuity of both these functions of this particular function at f of x equal to minus 1 and f of x equal to 1. And because the LHL not equal to RHL, the limit does not exist and the function is not continuous at these 2 points, right? Therefore, how do we write this? The function is continuous at x belonging to R except the points minus 1 and plus 1, right? And how do we represent that? We pull out our flower bracket and we call this as minus 1 plus 1. So that's the final answer for this problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.